Welcome back to the final lesson for Chapter 8. Chapter 8 uses the quadratic formula and the discriminant. Both of these terms may be unfamiliar to you, but today I get to use my singing voice a little bit, and so we'll be doing a little bit of singing, talking about the quadratic formula. I'll get to that right down here in just a moment. The quadratic formula is a formula that gives the solutions to any quadratic equation. We've been talking about solving things like this: y equals, or rather, 0 equals x squared plus 2x minus 7, for example. That one doesn't factor very pretty. But what we talked about in a couple lessons before is we said, can we write this as a product of two factors that multiply to -7 and add to 2? And in this case, you can see that it does not. This one is not simply one we can solve with square roots because you have the x to the first power term, and so we have to use the quadratic formula because the quadratic formula works all the time, every time. Now, if we taught you nothing about factoring, you can always use the quadratic formula, although sometimes the work that you do, and you'll find out here shortly, the work that you do is very tedious and very akin to making mistakes with one sign, and that screws up all of your answers. And so it's important that you recognize that the quadratic formula is kind of like the last resort, if you will. Some of you guys will go to it as the first resort. Again, some of these problems will solve much better if you simply use use factoring. But again, the quadratic formula works all the time, and so we don't want to take that away from you. So we're going to show it to you today. The discriminant is the part of the quadratic formula that's under the radical sign. All right, and so when we have something under a radical, we call that number, whatever this value is underneath, we're going to call that d, or the discriminant. So I'll be talking to you guys a little bit more about the discriminant when we get to the quadratic formula. So here it is, the quadratic formula. The quadratic formula works all the time, every time. It doesn't matter if the equation is one that can be factored. It doesn't matter if the leading coefficient is something other than 1. It works all the time. And so the quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we take these coefficients. The coefficient of x squared we call a, the coefficient of the x term we call b, and finally the constant term on the end is our c. And so those values, a, b, and c, are used in the quadratic formula. And again, the solutions where this thing is equal to 0, where ax squared plus bx plus c is equal to 0, all right, when that thing will be equal to 0 are the values of x, where we can get that from opposite b plus or minus the square root of b squared minus 4ac all over 2a. You guys are going to get sick of me singing that, but I will certainly sing it as we take a look at some of these examples in class. All right? So let's try an example here. We have x squared plus 7x equals 6. Remember, to solve any quadratic equation, we have to make it equal to 0. So we're going to subtract 6 from both sides. And so this becomes x squared plus 7x minus 6 is equal to 0. We have to have all the terms on one side, and it has to be equal to 0. If it's not equal to 0, you can't use the quadratic formula. Really, the only one that you would do that with is with square roots, but we'll get back to that in just a little bit. So let's identify our a, b, and c. All right, our a, b, and c are a is equal to 1. And b is equal to 7, and c is equal to -6. And so there's a space for those right here, 1, 7, and -6. Again, remember, it's -6. It used to be a +6 when it was on the other side. We brought it over, it became -6. All right, so let's write the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And now we're going to plug some numbers in. Now, remember, in the quadratic formula, when I sing it, I always say it's the opposite b. So if b is, in this case, +7, the opposite of b is -7. Now, if b happened to be negative, the opposite of that would be positive, so pay attention to that. This is then b squared minus 4 times 1 times -6, all over 2 times 1. All right, and so now let's go ahead and do some simplifying. Now, they don't show a lot of the math in here, so I'm going to kind of do that over here in the margin. You have negative 7 plus or minus the square root of, and then this becomes 7 squared, which is 49. Remember, please excuse my dear Aunt Sally, you're going to do your exponent first. And on the back end of this, I always make this minus 4. You see, I always make this plus a negative. So now I've got negative 4 times positive 1 times negative 6. And the product of a negative, a positive, and a negative is going to be a plus. Now I've dealt with the sign, go ahead and do the multiplication. 4 times 1 times 6 is 24. All over 2 times 1, which is simply 2. Now, what do you get under the radical sign? You get 49 plus 24. And 49 plus 24 comes out to 73. And so this is opposite b plus or minus the square root of 73 all over 2. Now, the square root of 73. 73 is actually a prime number. And so it does not have any factors of it that are perfect squares. So I can't simplify this at all. My solutions are simply x equals negative 7 plus or minus the square root of 73 all over 2. All right, now, if I use the plus, that becomes negative 7 plus the square root of 73 all over 2. And if I use the minus, I get negative 7 plus radical 73 all over 2. So I tell you what, let's go back here and let's clean this up a little bit. Hopefully you're using pencil here. Let's take this one and let's, again, because it's plus or minus, one time we're going to use the plus sign, which is the plus right here. So it's negative 7 plus radical 73 over 2. And the other time we're going to use the minus. So with this plus or minus, you get a plus and a minus. Now, negative 7 plus the square root of 73 does not simplify, and so we're just going to plug that into our calculators. You should get something about 0.77. Again, make sure you do the top calculation first, press enter, and then divide by 2. If you type negative 7 plus radical 73 divided by 2 in your calculator recognizes order of operations, so it's actually going to do this division first, which is not what we want. All right, so you can either use parentheses here and then divide it by 2, or what you can do is you can simply plug in this calculation first, press your equal sign, and then divide by 2 when you get all done. All right, so on the other one, it's negative 7 minus the square root of 73 over 2, and that comes out to about negative 7.77. All right, now, can we think a little bit about what that is as a picture? Let's think about a quadratic equation and what the graph of a quadratic equation looks like. We've talked about this in the first chapter. The leading coefficient here is positive 1, right? So that means if this was a parabola, y equals, well, let's do it right here, y equals x squared plus 7x minus 6. The graph of that would open up, and it would have x-intercepts. Again, we found the two x values where y is equal to 0. So the x-intercepts would be at negative 7.7, 1, 2, 3, 4, 5, 6, 7, 8, so like right in there, right? And positive 0.7, so there's 1, so maybe like right in there. Since the leading coefficient is positive, I know it opens up. Now listen, I don't know much about this graph. I don't know the value of the vertex, and I really don't care. I do know that the y-intercept is negative 6, though, right? That's 0, negative 6. And I also know that the x-intercepts in this case are there and there. And we can get that from our two solutions from the quadratic equation. All right? So let's try another example. Let's take a look at an equation that only has one real solution. All right, so this one is already in standard form because it's equal to 0. All right, and so in this case, my a is equal to 2, my b is equal to negative 8, and my c is equal to positive 8. All right, so the quadratic equation, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so in this case, since our b is negative 8, we're going to do opposite 8, which is positive 8, plus or minus the square root of b squared. Well, this is negative 8 squared minus 4 times a, which is 2, times c, which is 8. All over 2 times a, which is also a 2. Now, just so you know, guys, I'm very, I really don't pay much mind to this sign right here, all right? Because I know that when I square a negative number, I don't worry about the sign of b so much inside the radical, because I know when I square it, whether it's positive or negative, it's going to become positive. So I don't really worry much about that sign. Just so you guys understand that, you know, again, you could just use positive 8 there if you wanted to, because when I square it, it's going to become positive 64 anyway. But going back to this then, this is then 8 plus or minus the square root of, And again, they don't show much math here, so I'm just going to do this over here. 8 plus or minus the square root of 64, because negative 8 squared is positive 64. And then on the back end of this, like I said, I like to treat this as plus or minus. And so it's negative 4 times positive 2 times positive 8. The product of negative, positive, and positive is negative. And then 4 times 2 times 8. 4 times 2 times 8 comes out to 64. And this is all over 2 times a, and that's 2 times 2, which is 4, right? So what is 64 minus 64? Well, that's kind of an obvious question. This is 0, right? And this is all over 4, because again, 2 times 2 is equal to 4. Well, whether I add or subtract the square root of 0, the square root of 0 is just 0, right? So whether I add it or subtract it, it's going to be the same exact thing. So I don't have to do my little arrows here and do 8 plus radical 0 over 4, 8 minus radical 0 over 4, because whether I add it or subtract it, you get the same thing. 8 divided by 4 is 2, and so this only has one solution at x equals 2. All right, so again, if you're thinking about this as a parabola, okay, leading coefficient is positive, so that tells me it opens up. The y-intercept of this thing is 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right in there. It says that we have one solution. So that means that my graph comes down and touches the x-axis at 2, and then it turns and goes the other way. It doesn't cross through the x-axis, otherwise it would have two solutions. In this case, it only has one solution because it just comes down and touches the x-axis and goes away. All right? So what about one that has imaginary solutions? Let's work through our quadratic formula and see if we can do one like this. All right? Once again, you have to get it in standard form first. We're going to subtract 5 from both sides, so this becomes negative x squared plus 2x minus 5 is equal to 0. And so in this case, a is negative 1, b is 2, and c is negative 5. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's plug them in. Opposite b is opposite 2 plus or minus the square root of 2 squared minus 4 times a times c. All right, all over 2 times negative 1. All right, a lot of negative signs in here. This is then over here, again, let's just kind of slide it in over here. This is negative 2 plus or minus the square root. And again, like I talked about before, I don't really worry much about this sign because I know when I square it, it's going to be positive anyway. In this case, since it's positive 2 squared, this is simply 4. And then minus, this is going to be, again, plus a negative 4. So negative 4 times negative 1 times negative 5, the product of three negatives is going to be a negative. So I know it's a minus there. And then 4 times 1 times 5 is 20. All over 2 times negative 1, which is negative 2. Okay? All right, under this absolute value then, under this square root then, we have 4 take away 20, which is negative 16. Negative 2 plus or minus the square root of negative 16, all over negative 2. So this is negative 2 plus or minus radical negative 16, all over negative 2. Okay, now we talked about this in the previous lesson. Remember, whenever you have the radical under the square root, the negative under the square root, that's just like an I, right? So this is the same thing as I times the square root of 16, and as you know, what's the square root of 16? Well, that's 4. So this last term, this negative 16 under the radical, is the same thing as 4i. So then we can write this as negative 2 plus or minus 4i all over negative 2. All right? Now, in the first part, we do negative 2 over negative 2, which becomes positive 1. And then if I use the positive and I divide by a negative, I get a negative, and vice versa. So really, this is still going to be plus or minus. Sorry, that got kind of messy there. 1 plus or minus, and then 4i over 2 is just 2i. So my solutions are 1 plus 2i and 1 minus 2i. Now, as you can look, you see that these two solutions are both imaginary. That means they don't exist in the real number plane. These are imaginary solutions. All right? So because they're imaginary, that means we can't see them. Let's think about the graph of this thing. Okay, let's just real quick talk a little bit about the graph of this thing. The graph of this parabola is one that has a leading coefficient of negative 1, and it has a y-intercept of negative 5. Okay? This parabola opens down. I don't know where the axis of symmetry is. In fact, I don't know much about this graph, but it might look something like this. All right? If you plug that into your graphing calculator, you might get something like that. You might get something that looks like this. All right? But you're going to get something that has a y-intercept of negative 5. all right? And again, I don't really know exactly what the graph is going to look like. You know, it might be something that comes real close, whoops, not quite touches. Maybe it comes real close to the x-axis but doesn't quite reach it and then goes back down the other way. Why do I know that it doesn't touch the x-axis? Because my two solutions are not real. I can't see them. So that means that this thing never crosses the x-axis. All right, so there are 4 checkpoint problems for you to try. This is going to take some time, so I expect that you do pause your video and try these, and it will take me quite some time to go through the solutions for them, but go ahead, pause your video, and try all of these solutions. We'll be right back with those worked out solutions. All right, for number 1, it is A equals 2, B equals 12, and C equals positive 16. Because again, when I add the 16 to this side and this side, it gets it over here. And so x equals opposite b plus or minus the square root of b, whoops, b squared minus 4 times a times c all over 2 times a. All right? And so when I plug all that stuff in, I'm just going to do the part under the radical in one step here. You end up getting equals opposite 12 plus or minus the square root of 16 all over 4. The square root of 16 is equal to 4. And so this becomes negative 12 plus 4 over 4 and negative 12 minus 4 over 4. Well, negative 12 plus 4 is negative 8, and negative 8 divided by 4 is negative 2. The other one, this is negative 12 minus 4 more, which is negative 16, and negative 16 divided by 4 is negative 4. Now again, a quick sketch of this thing would tell you that the graph opens up, it has a y-intercept of positive 16, and it touches the x-axis at negative 2 and positive 4. All right? I'm sorry, at negative 4. Right there. Okay, not that one. So that means it's going to come down, it's going to cross the x-axis, it's going to turn around and go back up here, and I'm going to kind of have to fix that a little bit, but you get the idea, right? It's going to cross at negative 2 and negative 4, and it's going to have a y-intercept of 16. All right, how about the next one? For number 2, you got to do a lot of work here to get this over here, so we're going to subtract 7x, and we're going to add 25. This becomes 4x squared minus 20x plus 25 is equal to 0. So a is 4, b is negative 20, and c is 25. All right? From there, we do x equals opposite b, so opposite of negative is positive, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And so I have this mess here. Now, simplifying underneath the radical, you get negative 20 squared. Make sure when you do negative 20 squared in your calculator, you don't just type negative 20 squared, because it's going to square it, then make it negative. We're going to square negative 20, which should become positive 400. So make sure you're getting positive 400 there. Very common mistake where people get the wrong sign there. All right? On the back half of this, this is then 20 plus or minus the square root of 400, and then a negative times a positive is negative, and then 4 times 4 is 16 times 25 is also 400, all over 2 times 4, which is 8. Now, under the radical, 400 take away 400, well, that's all gone. And so we simply have then 20 over 8 as my one solution. 20 divided by 8, well, 20 and 8 are both divisible by 4. 4 goes in there 5 times, goes in there twice. And so it has one solution at 5 over 2, or 2.5. Now, I've been kind of working through the graphs for these, so I'm going to draw a graph over here. You don't have to write this in your notes. But it has one solution at positive 2.5, which is right there. We already know also that our y-intercept is 25, which is way up there someplace. So this graph kind of comes down, touches the x-axis at 2.5, and then goes back up. It doesn't actually cross through it, otherwise it would have 2 solutions. All right, checkpoints number 3 and 4. For checkpoint number 3, it's already in standard form. So again, your a is equal to a equals 3, b equals negative 6, and c equals 6. And so this becomes x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to plug all of our stuff in here. This is going to be the opposite of negative 6, which is positive 6, plus or minus the square root of b squared minus 4 times a times c. all over 2 times a. All right, so now what? We're going to go ahead and simplify under the radical. Under the radical, this is negative 6 squared, which is positive 36. And then this is negative 4 times positive 3 times positive 6, so that's going to be a negative. So under the radical, we have 6 plus or minus 36, and then down here, because it's minus and plus, this is a negative. 4 times 3 times 6 is 72, all over 6. Now, under the radical here, we're going to kind of take a little sidebar over here. This is 36 take away 72, which is the square root of negative 36, because 36 minus 72 is negative 36. Again, the square root of a negative becomes an I outside, and the square root of 36 is 6. And so we can replace that square root of 36 minus 72 as 6i. So this becomes 6 plus 6i over 6. Well, again, we get to separate this into 2 fractions. This is 6 over 6, which is 1. 6 over 6, which is 1. And so it's 1 plus or minus 1i, or simply 1 plus or minus I. Now, number 4, if you got really frustrated with this one, it's because the numbers didn't come out pretty. Again, a is equal to 1, b is equal to negative 3, and c is equal to 3. And so x equals opposite b, well, it's negative 3, so it's positive. Opposite of negative is positive. Opposite b plus or minus the square root of b squared minus 4ac. Sorry, that kind of ran together. All over 2a. So, under the radical, we then have negative 3 squared, which is 9. Again, positive 9. So this is 9, and then minus 4 times 1 times 3, which is minus 12, all over 2. Now, this one actually is kind of nice that it doesn't simplify, because it makes our life pretty easy. This is 3 plus or minus, and again, 9 take away 12 is negative 3, and so we have negative 3 under the radical. That is simply square root of 3i, or square root of 3i times the square root of 3. Okay, so we bring the negative out to make it an I, and then we take what's left over is radical 3, and this is all over 2. Now, I would be satisfied with that as an answer. In the textbook, sometimes they'll make this as 3 over 2 plus the square root of 3 over 2, and then put the I on the end. So again, square root of 3 over 2 is my fraction, and then they just chuck the I there on the end. So 3/2 plus square root of 3 over 2i. That's how they might write it in the book, but like I said, I am perfectly satisfied with that result there. All right, so our last order of business then is to talk about this idea of the discriminant. And the discriminant kind of comes from the pictures we've just been talking about. We said if this b squared minus 4ac in the quadratic formula, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a, this part under the radical sign, if that number happens to be positive, all right, when b squared minus 4ac is greater than 0, that means that I'm going to have 2 real solutions. Okay, 2 real solutions. And so the graph has 2 x-intercepts. Again, if this number under the radical is positive, then when I take the square root of it, I'm going to get the plus and the minus. So I'm going to get 2 solutions. What if that b squared minus 4ac is equal to 0? Well, if this whole business is equal to 0, then I get one solution, negative b over 2a. Right? Because whether I add or subtract the square root of 0, I basically get the same thing. This one has one real solution. And so the graph has one x-intercept. As a visual, this one is going to look something like this. This one is going to look something like this. Just touch it and go away. When this number here is negative, that means that my 2 solutions will be imaginary. So it has 2 imaginary solutions. Now we can't see those solutions. So if we're thinking about a graph and what a graph might look like, that would be something that kind of comes down and goes away but never actually gets to the x-axis. Or maybe it comes up and goes away but it never gets to the x-axis. Those are pictures that have no solutions. So they have no real solutions that we can see, but we can come up with those solutions by using our properties of complex numbers. The graph has no x-intercepts because it never touches the x-axis. All right, so let's use the discriminant to figure out how many solutions each of these ones have. All right, in letter A, okay, we know that the discriminant, remember the discriminant is just the part under the square root. It's b squared minus 4ac. All right, and so for letter A there then, the b squared minus 4ac, again, a is 1, b is 6, c is 5. And so this would be b squared minus 4 times 1 times 5. And then this is 36, take away 20. Well, who cares what it is, all right? Because the fact that this is 36 minus 20, that means that I got 16 under the radical, right? So that means that this part right here is a 16. So we're going to run out of space here, but this is then opposite b. So opposite b plus or minus the square root of 16 over 2 times 1. Now, the square root of 16 is 4, right? So this becomes negative 6 plus or minus 4 over 2. We're going to use once with a plus and once with a minus. Negative 6 plus 4 over 2, that becomes negative 2 over 2, which is negative 1. And this becomes negative 6 minus 4 over 2, which is negative 10 over 2, or negative 5. So I get two solutions at negative 1 and negative 5. Two solutions at negative 1 and negative 5. All right, what about this one? This is b squared minus 4ac. In this case, a is 1, b is 6, and c is 9. So this is b squared minus 4 times a times 9. All right, and so this is going to be 36, right? And then this is going to be 36. 36 take away 36 is 0. So that tells me the part under the square root is 0. So this becomes opposite b plus or minus the square root of 0 all over 2 times 1. Well, this is gone, right? So it's negative 6 over 2, which is negative 3. Has one solution, it's at negative 3. For the last one, this is b squared minus 4 times a times c. Again, this is a negative, this is positive, positive, so this becomes 36. Take away, let's see, that's going to be 26, 52. And so 36 take away 52 is negative 16. So since this is negative, that says I'm going to get negative under the radical. That means that this one this would have two solutions, two real. This has one real. And this one has no real, but two imaginary. Okay? And so once I get the negative 16 under the radical, then this becomes the opposite of 6 plus or minus the square root of negative 16 all over 2 times 1. Okay, this is then 6 plus or negative 6 plus or minus 4i all over 2. And again, if you're not sure where I got 4i there, it's the square root of negative, which becomes the i. The square root of 16 is the 4. And now just reduce. Negative 6 over 2 is negative 3. And then 4 over 2 is 2, and so it's negative 3 plus 2i are your two solutions. And they're both imaginary, right? And they're both imaginary because the part under the radical was negative. Last checkpoint problems here. We'll go ahead and I'm going to put the solutions up for you. I want you guys to try them, and I'll put the solutions in here in just a few moments. You can check yours against the originals, and if you have questions then during class, we'll actually work through the solutions. For number 5, you get a discriminant is equal to negative 4. Since the discriminant is negative 4, that says that this has two imaginary solutions. Okay, two imaginary solutions. And those solutions are at 4 plus or minus I. Okay? In number 6, you get the discriminant is equal to 4. Since it's positive 4, that means it has two real solutions. And those two solutions end up being x is equal to negative 3 and x is equal to negative 1. In number 7, your discriminant comes out to 0. Since the discriminant is 0, it means it has one real solution, and that's equal to positive 1. And then finally, for the last one, you get a discriminant of 20. So that means it has two real solutions. And those two real solutions are at negative 3 plus or minus radical 5. So we will go over the specific steps for those tomorrow during class, but those are the solutions to those problems. And that concludes chapter 4.